My name is Robert. I'm a startup founder here from Amsterdam, and today we're going to do self-hosting of AI. So, as the warning goes, do this at home because it saves you money and it's fun. So today we're going to do a face-off between OpenAI and NVIDIA's H200. So H200s are one of the high-end NVIDIA chips out there. And we're going to use a platform called Mitevs. So Mitevs is a GPU provider, a neo cloud. Those following semi-analysis will know that it's a gold one. There's one better, CoreWeave. And Mitevs is Dutch actually, it's a BV, so that's fine. As in the introduction, we're going to try to see if we can figure out, can we beat OpenAI in inference dynamics? And for that, we have this back of the envelope calculation. So an NVIDIA H, and I see now that this is a hallucination from the machine. An H200 GPU costs $230 per hour. For that, you get a managed Kubernetes cluster with it. And if I look at GPT 4.1, you pay per million tokens. So you have to calculate, okay, if I need to do that per hour, then how many dollars, cents per second can I do with these tokens per second? Believe the math, it's going to come out at $0.04 per second is kind of the inference dynamic point. But GPT or OpenAI has two pricing tiers, so the input and output tokens, because generation is more expensive than input, of course. So you pay $2 for a million input tokens, and you pay $8 for a million output tokens. So typical task where it's 4 cents is $2. That makes 2 cents times a million. We need to be able to generate roughly 20K in input tokens, and we need to do roughly 5K in output tokens per second if we want to beat OpenAI. So then we have now our North Star. This is what we're going to try to beat. So the last thing is also hallucination. Don't think about it. So now, let me get my cluster. Oh, wrong. How do I get one screen? Yeah, nice, perfect. Thanks. Get the right one. Yeah, so this one. Full disclaimer. There's always a demo effect. So I tried it out before, so I know it's going to work. It's good. But I did it just before the demo, so hopefully that's okay. And it's also a good thing because if we look at what it takes to put up a managed cluster on Arribas, it takes roughly 10 minutes here to get the managed cluster. And then we did roughly 2 minutes to get the node or the GPU, let's say. And we can actually see how that looks on the internet. So here we have, this is our Arribas cluster. Cluster overview. It's running a GPU operator. GPU operator are provided by NVIDIA for these managed Kubernetes clusters, which means that you don't have to worry about drivers. So for anybody who did self-hosting, GPU drivers are worst. And GPU operators help with that. And then we see that we have two node groups. We have a GPU node group and a CPU node group that got created 30 minutes ago. And here we see indeed that it's NVIDIA H200 with some nice NVLink. Back to the cluster. So I deployed that just before the demo. So we are running vllm production stack. So for those who don't know, like when you can run a pure inference stack, let's say you can do it yourself, but it's nice to have like monitoring around it, or it needs to be has stability if you want to use it in production. vllm production stack is done by the University of Chicago, and the second inference network is now very popular. It's called Aibrix. It was open sourced by Mitevs. Also very good. Also works off of managed Kubernetes, or works off Kubernetes more natively than vllm production stack. And there's also now NVIDIA Dynamo, but you can link that up with Aibrix. In general, I would recommend going into the stack for vllm. It's the actual inference engine, so not inference stack, but inference engine. And basically, you get the benefit of seeing a fight play out between Aibrix and vllm production stack on who's the best. And you just sit back and wait till you get a new deployment, and then you can use this. So we have here a cluster, as we saw here also in the UI. And so what we now have to do is we have to put an inference engine that is OpenAI compatible on this stack. Also did that before because it takes also a bit of time. But in general, what you see is, so these models that we are currently running are hosted on my private S3 bucket. You can also use the Hugging Face. And because it's hosted on S3, you want to stream it. So you see that it has LoRa dynamics, loading. We load it here, and then we see here. So we're, for those who already saw it, but like we're doing Llama 8 billion, 3.1, and it comes in 3 safe tensor model packages. So here we're loading them with Ron AI Streamer, so you can stream it directly from S3. And here you see the routes, for those that have ever seen OpenAI compatible routes, these are them. So chat completion, these kind of things. You can also have chat, the original endpoint. And here we see that the health is okay, so it's now running. And then here we see that there are 3 types of services running on this Kubernetes. For those familiar with Kubernetes, you deploy services. And they have a cluster IP and they have an external IP. And here, this is the magic IP that we have now created. This now, it's behind the load balancer, so we can now call the vllm router service on this IP. That's super nice. Actually, I did a test here, and so one of the things that we use to test if you are successful in deploying your custom model is we ask it to do something that a normal model would refuse. So, for example, here we would ask it, what are the steps to make meth? Normal models would say, I'm not allowed to do this. Llama actually is quite lenient, it already does it. The obliterated version does it even better. So that's how we test, and we also use NemoGuard. So NemoGuard is made by NVIDIA. It's basically a filter, so it tries to resist bad requests. This is how we know that we're running the right model in production, as a kind of vibe check, let's say. So the vibe check has been done. Now the question is, can we win the benchmark? And I should have cleaned this before, because now you already see the results. That's live. So basically, what are we doing? So in the vllm production stack, actually here also a benchmark. It's called a multi-round Q&A. So what we're going to do, we're going to spin up a lot of people asking questions to the vllm inference. Because we know this North Star, 20K and 5K output. So we're going to try to see if we can hit those numbers with this it's bash script, and it basically starts asking a lot of questions. These questions are I forgot the data set, but it's an open source data set with Q&A questions. So it's just a matter of getting to the right amount of input and output tokens, because we have a limit of 4,000 roughly here. So I'm going to run it. It's going to warm up. Now it's asking a lot of questions. So as you see here, you see user 130 has an unfinished request, so it's now waiting. So all these things are spinning up. It's quite a powerful MacBook. That's why it's possible to overload the system or to get to inference dynamics that you can do with OpenAI. And so it's now building all these. We have now roughly we have now 300 users asking questions to this endpoint, trying to get it to tokens per second that we need to win from OpenAI. This is going to take a bit. So I don't know if you see, but like users keep adding. So we have set the upper limit for 500 questions, and now sometimes, like here I see 217, is still waiting for a question. So that's why it's multi-turn. Set it on 2 turns max. So okay, now it's finished. So now we're waiting for all the questions to be answered by the vllm inference engine. And now we have a performance summary. So the QPS is what we try to do. It's 1,000 requests per second, and of course we have multiple users. We have a processing speed of 13 requests per second from this inference stack. A request on the fly is a dummy metric. Input tokens per second, we are getting to 23,000 tokens per second. That's nice, because the input or the benchmark that we had was 20K. And the output tokens per second here are 6,000 tokens per second, which gives us an average generation throughput per request of 31 tokens per request per second, and an average time to first token of 1 second. So I don't know if I like the analogy of a pipe. So if you want high throughput, you're going to have to wait longer for the first, like the time to first token is going to increase, but you get higher throughput. If you want lower throughput but lower, so if you want lower time to first token, you're going to have to accept a lower throughput. These are the inference dynamics that you have with any model. So yeah, back to the presentation. So actually maybe I can also show you here. So this was not a test. So basically here we see this was our little inference test. And I can assure you this needs 100, but I see that there are some UI issues here, but we are almost hitting the 100% GPU utilization. There's also spikes in memories, these kind of things. So yeah, we did 23K. So we have beaten the math, and we did 6K back. So we have created on H200 an inference dynamic that actually beats OpenAI in terms of cost. So nice. We have saved some money. I think we spent roughly €1 now, answering roughly 20K questions. So yeah, the H1 wins. That's basically the moral of the story. Now, what do I have here? So these are 3 URLs. On the left is Nebius AI Cloud. So this is the inference stack or the GPU Neo Cloud that we're using to run this. So you want these managed Kubernetes services because it makes it a lot easier. The inference engine that we used was the vllm production stack. It's in the middle. Again, built by University of Chicago, active maintainers, and it comes with observability, it comes with KV cache, a lot of inference dynamics optics. And then on the right we have Aibrix. This is the inference platform from ByteDance. You can also use Aibrix to do the same, but then it's basically the same, different. Both vllm production stack and Aibrix underneath use vllm. So that's also why it's called vllm production stack. Yeah, that's it. Thank you very much.
Questions? Sorry, so that was an 8B model, right?
Sorry, what?
That was an 8B model, right?
Yeah. Llama 3.1 8 billion.
So that means that GPT 4.1 runs as fast as an 8B model?
So, of course, 4.1 is bigger. Yeah. So they achieve very good potential. Nobody knows. So we did choose a smaller model to make it easier to beat it. But so you can run an 8 billion instead.
But it is impressive that optimization they did that too.
Yeah,
right?
Exactly. No, the inference dynamics of OpenAI in general are very competitive, and they do it pretty well. Yeah.
Thanks.
Great presentation, thank you. What are the sort of the quality versus price trade-offs here? Because I saw like a couple of typos in the output, for example. Like, of course, like 4.1, so you have the better models. How do you distinguish between that?
Yeah, so you now have full control of what you're running in your inference stack. So if you need a model that's very good at medical questions, it's smart to choose maybe a fine-tuned Llama model that is fine-tuned on healthcare Q&As, and that gives you the potential to achieve the same or better performance with a smaller model than OpenAI. So it's really dependent. The quality output is really dependent on what the base model is that you're running, but you can optimize for that. You have full control.
Makes sense. Thanks.
Hi, thanks for the presentation. I had a little mathematical question. If it's 230 per hour, it's 4 cents per minute, right? Not per second.
Yeah, that's a good one. I think I actually went for the divided by 60. Yeah.
Because I think you beat the benchmark by about 60 minutes.
Yeah, no, that's true. That's true. Yeah.
I did have also a follow-up question. What is the largest model you can run on H200?
So that depends a bit on what you mean by running efficiently on a H200. For example, you can put some of the memory outside. It depends on the bench, like the batch size that you want to run. In general, an H200, let's say like a 72 billion. Is I think the upper limit. But if you go to like batch size of 1, you can get bigger models in there. And there's a lot of options to do with quantization, of course, that reduces memory footprint. So it's there's a lot of room to play with. In general, one doesn't have to limit themselves to one GPU. I think that's one of the powers of these inference stacks. Is actually it's very easy to say I want now 8 GPUs, and then vllm production stack and Aibrix manages routing those requests, splitting them per GPU. So that's one of the benefits that you get from using an inference stack.
Thanks.
And thanks for the correct math.
Thank you for the presentation. I'm going to ask a really obvious question. And it's going to be like, what do you use it for? Before you answer, I'm going to kind of explain my rationale. Because yes, it can be a little bit more expensive, but you've got SLA, you've got throughput, you've got uptime, security, all this stuff to worry about. And like, to reframe my question of what you use it for, does it make sense to do this given like how much volume would you need to actually make this work? Like, I don't know, because it's going to be quite hard to, I don't know, maybe try to answer. Does it make sense what I'm trying to say?
Yeah, no, I get what you mean. So you mean it's a lot of hassle. So why take that, right? I think so. Obvious one is cost. If you are really running like major workloads, if you do it yourself, you can save a lot of absolute money. That's it. Second could be that the amount of customization that you can achieve with these models is a lot different. Is a lot bigger than let's say an OpenAI endpoint. So in general, if you're asking generic questions that have average knowledge that is spread around the internet, I wouldn't take the effort of doing this yourself. If you have specific knowledge, or you have privacy concerns, or a certain cost component, then I would say do an inference stack.
Question that is something related to this. I'm curious about what will be the growth of the cost if you scale these horizontally for whatever reason. Perhaps we need to serve different geographies, we need to run some stuff on the edge, we need to allocate different power, different geographical location, and then this thing needs to scale like that. So what would be the implication in terms of the overhead of orchestrate over the years?
Yeah, so we are now running this in Paris. I know that Mitevs now has Finland and Paris. They're going to get US soon. If you want to run it, you can run it on any other Neo GPU provider or like classical hyperscalers. So in terms of region, like getting it in the right region, I think you will be able to do it. You of course need to always deploy a new inference stack in that region and then route to that IP. Edge, of course, that's nice. You don't have to send it to a server at all. So that's so one of the things you could do actually, you make a server with a model that's able to be run on the edge, and then people can actually swap. They would not see a difference between having in terms of latency, but they could swap. So this is, you could think, exotic kind of inference dynamics where you mix and match. Yeah, and other than that, so there are now, so for example, Cloudflare does AI workers, so you could run GPU serverless, but so now it becomes quite complicated, because now you have a serverless, and you need Kubernetes to run this, but you can do vllm stack and like a Dockerized version, so it becomes quite complex quite fast. Yeah.
Thank you.
Right.